Assalamualaikum and greetings. We are Group 6 from Section 82 and we will be presenting our group project for this subject. So first and foremost, our project involves 3 different topics in the subject, namely force equals to mass times acceleration. Next is work and energy, and then the next one is impulse and momentum. First, we will talk about force equals to mass times acceleration. So it is a law that is derived from Newton's second law of motion that states that a force of an object is equal to its mass times its acceleration. So in this project, every movement from either the putter or the ball has their own magnitude of force due to their own mass. Next, we will discuss work and energy. So work and energy can be summed in the equation below, where the change in work done is equals to change in gravitational potential energy plus change in elastic potential energy plus change in kinetic energy. So in our project, VE is equals to 0 because there is no elastic object used. And when it comes to delta U, it has no constant force, there is no force by cable, and there is also no friction that is being calculated in the equation. So delta U is equals to 0. The next topic is impulse and momentum, where impulse is the product of force and the time the force is in action, which is derived from F equals to ma just now. So in this equation, A in the equation becomes the change of V divided by T. So now we get the equation Ft impulse equals to mass times the change of velocity, and then the time is calculated in seconds. Since mass times velocity is equal to the momentum, then m times delta v is equals to the change of momentum. These parameters can be related with impulse. So through this equation, it forms the impulse momentum theorem. It relates impulse to initial and final momentum of action. So it becomes mv2 plus f times the change of time equals to mv1. The equation mentioned earlier is then used to form the conservation of momentum equation, which is particularly used in a collision situation between 2 objects, where the summation of mass times velocity final equals to the summation of mass times velocity initial. So from these changes of velocities between 2 objects, a value called coefficient of substitution can be achieved. This value varies between 0 to 1. 0 means the objects are fully attached, and 1 means the objects fully detached from each other. So this coefficient can be different due to objects having their own level of elasticity affecting the velocity magnitudes. So when the velocity values change, the coefficient value also changes. So the system used in the project to push the ball, we use a mechanical putter. It is made of a hammer, a steel rod, and 2 supporting bottles. So the supporting bottles will support the rod, and the rod will support the hammer. And then for the different weights, we use drinking can and then plasticine. So the drinking can, we cut it in half, and then we put plasticine to increase the weight. So that drinking can is attached to the hammer, so that the weight can be increased. So the ball, we use the 3 cm diameter rubber ball, and then the track, we use cardboard with metal plates as the walls. So here is the system track. We made the track based on what is constructed. From A to B, there's a wall, and then from B to C, there's another wall before it reaches D as the finish line. So as a result of us building the track, this is our final result as in the right picture. So how does the system work? So at the putter, the hammer rotates at a fixed axis at an angle vertical from the ground. So when it's released, it creates a force that pushes the ball throughout the track. The ball will hit walls B and C, which changes the velocity and acceleration. So through these changes of velocity, we will calculate the coefficient of restitution.